Good morning everybody. Today I will discuss about spectroscopic techniques and its application. So at first we go through the chapter. There are some basic terms that we know at first. So let's start. Wavelength. So, what is wavelength? Here the definition: the distance between two consecutive crests or troughs is called wavelength. So, if we explain it, if there is a wave, there is a wave like this. So, the distance between two consecutive crest or trough. So therefore, the distance between this is also wavelength. This is also wavelength, and from this point to this point, this is also a wavelength. Okay. So if we simply say that if there was a circle, and if we cut into one point and arrange into this type, so full form is a wavelength. See here, if we let from this point and into this point, so if we attach to this point into this point, there is a complete circle. Okay, so simply we said that the distance between two consecutive crests or troughs is called wavelength. Okay. And the wavelength is denoted by lambda. Wavelength is denoted by lambda, and unit of wavelength is unit of length. So the unit of wavelength is unit of length, that is centimeter, meter, etc. Okay. So any problem with the wavelength? Okay. Next is frequency. So the definition is the number of occurrence of an event that can pass through a definite point per unit time is called frequency. So here said that the number, so frequency is a number, and which number? The one event that can repeat. How many times repeats in unit time? That is the frequency. So if we said that a frequency, here a complete event is from here to here. It is a complete event. So this complete event in unit time, how many times repeat? That is the frequency. Okay, that is let in 1 second there the wave go from here to here. Let's in 1 second the wave go from here to here. So in this point to this point there are how many complete event? There is a 1 and here to here 1, 2 and here to here 1, 3. Total 3 complete event. So in 1 second there is a 3 complete event. So the frequency is 3. Okay, and frequency is denoted by frequency is denoted by nu. Okay, and unit of frequency is unit equals to, so here the frequency is a number of occurrence per unit time. So the unit equals to per unit time, that is second inverse. Or there are others unit, that is hertz. Okay. So next is wave number. So the number of waves that exist over a specific distance, that is unit length, is called wave number. Okay, and wave number is denoted by nu bar. This is nu bar. It is inversely proportional to the wavelength. Okay, it is inversely proportional to the wavelength. Unit of wave number equals to inverse of wavelength, that is centimeter inverse, meter inverse, etc. And therefore nu bar equals to 1 by lambda. Nu bar, that is wave number, equal to inversely proportional to the wave length, that is 1 by lambda. So nu bar equal to 1 by lambda. Okay, again nu bar equal to nu by c. This is the frequency and c is the speed of light. Okay, so if we put this value here, nu by c equal to 1 by lambda, or nu equal to c by lambda. This relation is important for mathematics. Okay. Next is electromagnetic radiation. So what is electromagnetic radiation, or not electromagnetic radiation? So next is electromagnetic spectrum. What is electromagnetic spectrum? Electromagnetic spectrum is a combination of many types of electromagnetic radiation. That is, there are so many electromagnetic radiation like cosmic rays to radio waves. If we arrange them in increasing order of energy, so the lowest energy is radio wave. Okay, then microwave, then infrared, that is IR, then ultraviolet, radio wave, microwave, infrared, visible, ultraviolet, and then X-ray, then gamma ray, and then cosmic ray. Okay, so the lowest energy is radio wave, then microwave, then infrared, that is commonly known as IR, short form. Infrared, then visible, then ultraviolet, UV, then X-ray, gamma ray, and cosmic ray. So from left to right, if you go from left to right, the energy is increases. Energy increase. So if we know the energy increase or decrease, then we also know the lambda or wavelength and frequency or nu. So the relation between energy and frequency is E is equal to H nu, equal to H nu, and from here E equal to H into nu equal to C by lambda. So equal to Hc by lambda. So as energy is increases, here also frequency increases. Frequency also increase, and frequency increase or energy increase, therefore lambda, that is wavelength, decreases. Wavelength decrease. So if we go from left to right, the energy increase, frequency increase, and wavelength decreases. Okay. Now we know about some selection. There are some selection rules in spectroscopy. So if we know the basic of spectroscopy, what is the basic of spectroscopy? There is, in spectroscopy, the matter accept energy from electromagnetic radiation, and therefore in their ground state there are some electrons, and these electrons are jump from ground level, lower ground level to higher energy level, lower energy level to higher energy level. that is here. It is gain energy and go from here to. So the basic is the electron gain energy and go from lower energy level to higher energy level. This is the main theme of spectroscopy. Okay, so there is some basic rules. So which transition from here to here, which transition occur and which is not. So these rules are called selection rule. There are 3 selection rules. First is spin selection rule. Spin selection rule. So, what is spin selection rule? Spin selection rule. The spin selection rule is there should not be change any spin orientation during transition. So there should not be change any spin orientation during transition. That is, if the electron is singlet, then in ground state the electron is singlet, that is yes. If transition from lower energy level to higher energy level, there also be singlet. That is, singlet state to singlet state transition is allowed. Singlet to singlet is allowed. Triplet to triplet is allowed. But singlet to triplet is forbidden transition. Forbidden transition. Okay. This is the spin selection rule. That is, singlet to singlet transition allowed, triplet to triplet transition allowed, but singlet to triplet transition or triplet to singlet transition is forbidden. The second selection rule is symmetry rule. The symmetry rule is there is no change in symmetry during transition. That is, during transition the symmetry will be same. So the symmetry of ground state and symmetry of excited state is same. That is, no change of symmetry. Okay. This is the symmetry rule. And third is angular momentum rule. Angular momentum rule, there during transition, this is the ground state and this is excited state, and the electron go from ground state to excited state. The transition will occur only when the difference of angular momentum is 1 unit. That is, if the angular momentum of ground state is I, so the transition occur only when the angular momentum of excited state is I plus 1. That is, difference is I plus 1 minus I, that is plus 1. The difference only when is plus minus 1 the transition is occurs. This is the angular momentum rule. Okay, in next class we discuss about the electronic spectroscopy, that is UV visible spectroscopy, and